Okay, so we're going to compute quartiles for a data set. So quartiles, as because it's got the word quarter in it, what it's going to do is it's going to quarter your data. So it's going to split it into 4 equally sized areas. So if this was my data set here, we're going to do is split it up like this. In each one of these areas is going to be 1/4 of my data, or 25% of it. Or close as we can to 25%, as you're going to see in one of our examples. Not exactly, just because we don't have data that easily is split by 4. So in previous sections, we learned how to compute mean and median for a data and a median of a data set as measures of center. So sometimes it's useful to compare measures of position other than the center to get a more detailed description about your distribution of data. So when you did a median, and a median was kind of the same thing, but a median was the center of your data, but it's also a position. It's the data point that is exactly in the center of your data. So it is a position. So what we're going to do is look at other positions. So we're going to look at quartiles, and we're going to look at something called percentiles. So quartiles divide your data into 4 approximately equal pieces, like I said, right here. And how we're going to split that is you're going to have your first quartile, and we use this Q subscript 1 to denote it, and it's going to separate your lower 25% of your data from your upper 75. So it would be right here. So this is 25 below it, 75 above it. The next, we're going to have our second quartile, which we use a Q2 for. That separates my data into 50 below it and 50 above it. So this is going to be the exact same thing as your median. So your median is the point where your data is split equally in half, and that is also called your second quartile. And then your third quartile, your Q3, would be here. So 75% of my data is below my Q3 and about 25% is above it. So like I said, this is approximate. It's never going to be, well, it could be, but for the most part, it's probably not going to be exactly 25 below, 75 above, or 50-50 in between. You know, it's not going to be perfect. Okay. So there are multiple ways to compute a quartile. So we're kind of sticking to one method here. So here we're going to use a locator, essentially like a locator function. So there are several methods to computing quartiles. And just, you know, if you use your calculator, it may compute it a little differently than if you did it by hand. So if you're trying to do homework and you're using a calculator and you're getting answers and it's saying they're wrong, try computing it by hand, just as a suggestion here. But your book's method for this, and like I said, there's been several methods. This is the third one that I know of for computing quartiles. We're going to get similar results. The numbers might be just slightly off. So always remember, just like when you're looking for a median, you need to arrange your order in increasing order. So smallest number all the way up to your largest number. And we're going to let n be the number of values in the data set. So it's your sample size. So to compute the second quartile, what we're going to do, and I'm going to add an extra part in here. So your first quartile, not your second quartile, your first quartile is just going to be 0.25 times n, because that's 25% into your data. And then your third quartile is 0.75 n. So it says here just to compute your median, but if you want to do your median or your second quartile, we can go through and arrange your data and count ourselves in the center, but you could also, like you're going, this is 25% in, this is 75% in. Well, your second quartile is supposed to be 50% in. So if you did 0.5 times n, it's going to help you find this. So anyways, what this is doing is this is telling me the location in my data. So I'd have to basically go through my whole data and count where this value is, but it was ranged from smallest to largest, yes. This is going to tell me the location of my quartiles. So it just all depends if you're looking for your first, second, or third. If you're going to multiply your n by 0.25, by 0.5, or 0.75. So what's important is after you do that, two things could possibly happen. So you're trying to still find that location. So you could end up finding, your 25%, your 75, your 50% the way into the data and get a whole number. So if you get a whole number, the quartile is the average of the number in position L. And position L plus 1. So it's kind of like when you're doing a median, if you were in between two values, you average them out. Well, if we do a 0.5 times n and we get something that's, like 5, then I know that the number in the 5th position and the 6th position need to be averaged to get my mean, or sorry, get my median. Same thing is true if it's a quartile, if your first quartile or your third quartile. If L is not a whole number, we are going to round up to the next whole number, and the number in the position is going to, the quartile is the number in that position corresponding to the rounded up value. So in that case, if I find L and it's like 11.7, then I'm going to round it to 12, and I'm going to count until I find the number in the 12th position, and that would be my quartile that I'm looking for. Okay, so we're going to do an example of this. So the following table represents the annual rainfall in inches in Los Angeles during the month of February over several years, and we want to compute the quartiles. So I'm going to split this into 3 pieces. So quartiles split my data into 4, but I only have 3 different quartiles. So you're going to have your first quartile. So what I'm going to do is I'm going to figure out the location of this number by taking 0.25 times n. So we need to first figure out what n is. So if we count this, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 data. So that means this is 30, 45. I have 45 points in my data set. So my n is 45. So if I want to find my first quartile, I'm going to take 0.25 and multiply it to that 45. I definitely remember this isn't a whole number. Yeah, so we get 11.25. So because it is a decimal response, we're going to round this up to 12. So Q1 is the 12th number in the data. So remember, first we were supposed to order this data from smallest to largest. I kind of actually forgot to go over that because this data was already arranged from smallest to largest, but we just want to find that 12th value. So we count to, this is my first, second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th, 11th, 12th. My Q1 is going to be the 0.92. So like I said, all that L is it's telling you the location. It's what we consider a locator function. All right, so let's say I wanted to find Q2 now. That's my second quartile. So that's my halfway between point. So that'd be 0.05 times n. And n is still going to stay 45 because we still have 45 data points. So if I do that, I'm going to get 22.5, which if I round that up will be 23. So remember, we're always rounding up. We never round down, always up. So I need to find my 23rd data point. So if this is ordered from smallest to largest, I just count till I get to 23. Okay, so I know this is 15, 16, 17, 18, 19, 20, 21, 22, 23. So my Q2 is going to be 3.21. See, my one didn't show up here when I put it down. Okay, so my very last one is my Q3. So that is going to be the data point that splits my data between the 75% that's lower and the 25 that's upper. So it's going to be 0.75, that's 75% times n, which is going to be 0.75 times 45, because we still have the same data. Oops, put too many things in my calculator. And that's going to be 33.75, or we're going to round it up to 34. So this is 15, 30, 31, 32, 33, 34. Okay, let's make sure I have that down. Okay, so these are going to be my quartiles. So like I said, it splits my data as close as we can into like equal halves. We got 1, 2, 3, 4, 5, or equal halves, I'm sorry, equal fourths. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 points here. And then from here to the next quartile, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's close to 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Close to 11 again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So as close as we can, it broke it up into, we got 11 points in some places and 10 in others, but it is as even as we can get that data. All right, so this is just showing you that same thing again. So we should, in this range, let me put my values back in here. So this right here marks my first quartile, which we know is 0.92. This marks my median or second quartile, which is 3.21. This marks my third quartile, which is 4.89. You can see it kind of fits in the scaling. Here's my 4, it's about 4.89. So we should have roughly like about 11 values here, 10 here, 10 here, 11 here. Not going to be perfect, but okay. So as I was saying, it's an attempt to break up that data. So what we see by this with quartiles, especially when we got two values close to each other, like this 0 and the 0.92. So my smallest value is close to 0 or is 0. This tells you that I have, this is rainfall. About 25% of my rainfall is going to be in this area of like less than 1 inch. So 25% of February's, because this is different February's. So the following data is Los Angeles rainfall data with, and I think it's all for the month of February. Let me go back a second. Yeah, so during the month of February. So this is telling me that 25% of February's are going to have less than, that first quartile is 0.92 inches of rain. It also tells me that 75% of February's have more than 0.92 inches of rain. So that's for that whole month. So I've moved on to the median. That's a halfway point. So 50% of February's have less than, or it could be more than because it's a halfway point, 3.21 inches of rain. So it's giving us an idea, like how much rain do I expect to have? So it seems pretty common. Like I said, about a quarter of the time, we have less than an inch of rain in February in Los Angeles. Half the time, we have 3.21 inches. And you see there's a bigger range in this quartile. This one kind of shortens down again. But you see, this is really spread out here. So this is telling me that 75% of February's, because if I'm looking at my third quartile, 75% is below it. So 75% of February's have less than 9889 inches of rain. That also means 25% have more than that. So like I said, it's an interesting way to split up your data, and it splits it up in a meaningful way because we're looking at it as quarters. So when I have those quartiles, I know about how much should be below that quartile and about how much should be above that quartile. And like I said, one of the things I learned from this data is Februarys don't necessarily have a lot of rain because we got like 3 inches here, and a good half of these ones in this range are actually below less than 1 inch. We also see having lots of rain is very rare because this is at 25% of my data. And that's going from about 5 inches to rain to up to, what is that, like 16 inches? So that's a big range. So being out here is not very common. So like I said, it just provides some information about how this data is broken up. Also, one of the things we'll see is that because this data is more squished together down here and more spread out down here, it gives me an idea of how this data would look in a distribution. So if I have that long tail, that means that I'm getting less and less rain. So I'm getting smaller and smaller to an x-axis. So I can see that this data is very skewed. It's very skewed to the right. Okay, so take a minute and pause. You're going to find the lengths of Carolina wolf spiders in millimeters, or this is the data of the Carolina wolf spiders in millimeters. You're going to figure out the first, second, and third quartiles for the length of these spiders. Okay, so these wolf spiders are, once again, they are arranged from smallest to largest, so you don't have to do that extra part there. So my first quartile, if I want to find the location, it is going to be, and we know in the past, 40 spiders here. So we are going to take 2.5% or 0.25 times 40. And this is going to give me 10 exactly. So if you went back to what we were saying earlier, so I can get my calculator out because I'm going to have to do some calculations here. What we have here is that if I want to figure out my first quartile, it's going to be the average, or exactly in between, the average of the value in the 10th, and then we go one up, so the 10th and 11th position. So what's going to be is that this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is my 10th position. This is my 11th position. So if I want my Q1, it's just going to be the average of those two numbers in those positions. So in the 10th position, we have 18.9 millimeters for that spider. And then 11th, it's 19.4 millimeters for that spider. Divide by 2, we're going to get 19. I get 19 something. So it's a 5. I think it's 2.5, or I mean a 1.5. got to put it back in my calculator. Sorry about this. There you go. Yeah, 19.15. So this doesn't always work out. So the last data set, we kept getting things that were decimal for locations, and this one's going to all be whole numbers. That doesn't always happen. So sometimes it's like your median's a whole number, and then the rest of your data is going to be decimals, or your median could be the decimal, and the other two can be whole numbers. But it's not all quartiles are whole number are going to be in whole number locations, or sometimes it's or it could be all decimal locations, but it can always be a combination of those as well. All right, so my median or my Q2, that is 0.5 times n, which is 40, and that's going to give me 20. So my second quartile is the average of the value in the 20th and 21st position. So we know this is going to be 20 here, and this will be the 21st. So those values in those two positions will be 24.7 plus 24.7 divided by 2. So it's going to be 24.7. That was an easy one. Okay, so the very last one, we're going to look for that Q3. So that's going to be the 0.75 times n, which is still 40, and this is going to give me 30. Q3 is the average of the value in the 30th and 31st position. So it's going to be this one is my 30th position, and this one here is my 31st position. So my Q3 is going to be the average of 30.6 plus 31.6 divided by 2. I think it's going to be 31 something. Let me just double check here. So 30.6 plus 31.6, 1.6. Yep. 30.95, very close to 31. So our quartiles, our medians, all that stuff, we know it doesn't always have to be data. That's exactly, that is actually in my data set. Trying to grab a new color here. There we go. So what we have is like my data splits here. And my Q1 is going to be here at a value of 19.15. And that's going to split. And then this, my second part of my data is up here. And this splits at 24.7, which would make sense. It's going to be in between these two. And then my data splits again here at 30.95. That is my Q3. Forgot to label this one, my Q2. And then this is just the rest of the data. Once again, you know, certain things I can figure out here. Right now, I know that 25% of wolf spiders, or Carolina wolf spiders, are going to be under 19.5 millimeters in length. Like I said, it tries to give me some helpful information. I know that this is telling me that 75% are under 30.95 millimeters in length. Half should be below 24.7. But as you see, 24.7 is here and here. So that's halfway in between. Okay. So we can do, like I said, quartiles with the TI 84 plus. So if you did your one var stats, if you scroll down far enough, we did point out the median, but also right above it, right below it, are your first quartile and your third quartile. So right here, oops, got my pen messed. Sorry, this thing is not cooperating right now. There we go. This here, that's going to be your quartiles. And then this minimum value and this maximum value, also keep those in mind because you have to use those again when we do number summaries. Okay, so if you can, take a moment and plug this data into your list and do your one var stats and figure out what your first, second, and third quartiles are. All right, so as a reminder, you go to stats here and you go to edit. You get that first list. So in there, you're going to enter in your data. So the data we had was the how many classes students were taking. And what you would have had is some people were taking, we had one person taking 3 classes, then 1 class, then 3 classes again, 4 classes, 5 classes. Oops, just a second, lost my data. 6 classes, 4 classes, third classes, 2, 2. Remember, you just keep hitting this button to go down. Who was I? 0. We had somebody 0 classes, 1 class, 2 class, 3 classes, 2 classes, 2 classes again, 1 class, 0 classes, 5 classes, and 4 classes. So all my data is in there. Second click takes me up to the screen if you wanted to. So if we wanted to figure out those quartiles, we go to stats again. We move over 1 to calculate, and we want 1 var stats. So make sure you put in L1 as your list. You don't need a frequency or anything like that, and just go down to calculate again. Like I said, not everybody's calculator is going to do this exactly the same. So if you're having problems, just let me know. But like I said, just scroll down a little bit and we see those quartiles. So we see my quartiles. My first one is 1.5. My median is 2.5. And that my Q4 or my Q3 is going to be 4. And notice that my data was not in order. I could have put it in order if I wanted to, but if you're as far as putting in a calculator, it's not going to make a difference. You only have to do it in order when you're trying to do this by hand. So if I was to do this by hand, then I definitely want to make sure I get this in order. 3, 4, 5, and then I have 1, 2, 3, 4. Just counting how many of these I had. And then we had 1, 2. So if you do have to reorder it, remember we have 1, 2, 3, 4, 1, 2, 3, 4. That costs 1, 2, 3, 4, 5. So this is 20 data points. So just make sure if you had to reorder it, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18, 19, 20. Just to show you, once again, when we have repeated values, it might seem a little weird. But if I was trying to figure out my Q1, I'm looking at 25 of 20. So that is going to give me 5. So I need 5 and I need 6 to calculate my Q1. So it was giving me these two numbers and the average of 1.5. So that was correct. Like I said, It should, for the most part, match the calculator, and doing it by hand just isn't always. If I want my Q2, that's 50%. So that is going to be 10 and 11. So that'd be this number and this number, and halfway between them would be 2.5. And then Q3, that's going to be 0.75 of 20, which is going to be, my brain just shut down, 15 and 16. So let me see, 11, 12, 13, 14, 15, and 16. So the 4's here. So it's a little odd, but my data is splitting here, and it's saying that 25% should be greater than 4, but we see we have two values in that range greater than 4. So it's a little odd way you're considering it, but another way to think about it as it's splitting your data set like this. It's going, I should have 5 values here, 5 here, 5 here, 5 here. But it doesn't always going to make any kind of sense as far as your data goes, because we know looking at this that 25% is not greater than 4. That's why we say things are like approximate. Approximately 25% of my data should be over 4. Even though we have two 4's in here, we know that's not completely true.